All right, so we are going to start looking at angles of elevation and angles of depression, and then using all of our trig stuff. So the main thing you need to remember about an angle of elevation and an angle of depression is that it must touch, here's the key, a horizontal line. Now hopefully all of you guys know that a horizontal line looks like this. Oops, I guess it has to actually look. It looks like that. So if I'm talking about an angle of elevation or an angle of depression, that means something that comes off the horizontal. So both of these two come off the horizontal. That comes off a horizontal. That comes off a horizontal. Any of these could be angles of elevation, angles of depression. If I have something that looks like this, that is not an angle of elevation or an angle of depression because it does not come off a horizontal. Well, what kind of horizontal? What kind of line is this? Vertical. So the first thing you're going to need to be able to do, and this is really easy, but it's key, is to be able to identify angles of depression and angles of elevation. Angles of depression are not angles that are just really sad. Angles of depression are angles that go down off of the horizontal. Angles of elevation are angles that go up off the horizontal. So let's take a look at what I'm talking about here. So here we have a bird. We have a balloon. And we have the base of a mountain. And the guy in the balloon is horizontal with the mountain's peak, and the bird is horizontal with the top of the balloon. So I started to draw some angles here, and in drawing these angles, I can identify these angles as angles of elevation or angles of depression. Okay? So a horizontal line is right here. An angle of depression would be an angle that goes down from the horizontal. And usually you can relate it to two objects. So this is an angle of depression from the bird to the guy in the balloon. Angle of depression, angle 1. Angle 4 is an angle of elevation from the base of the mountain to the guy in the balloon. What would angle 2 be? From what to what?
From the guy to the bird.
Guy to the bird. What would angle 3 be?
Depression.
Depression. From what to what?
From the
Guy to the base of the mountain. Notice that since these are horizontal, all horizontal lines, what do you know about all horizontal lines? That's right, they're all parallel. So what could you say about angle 1 and angle 2?
They're congruent.
They're congruent because alternate interior angles are congruent when two lines are parallel. What would you say about angle 3 and angle 4? They're congruent. Why? Because alternate interior angles are congruent when lines are parallel. Everybody okay? All right. Angle of elevation, angle of depression, being able to identify those two. All right. So what makes this stuff important? Boom. Here's where it gets real. And you see a lot of words there, and I know you're already starting to hyperventilate and panic. But let's take a look. Yeah. This is the same thing. There's no difference. It does look fancier. So it's got a lot of moving parts to it, so you need to break it down. Okay, what am I looking for? Suppose you stand 53 feet from a wind farm turbine. And it's good to stand 53 feet away from those suckers because they will cut you. All right, so I'm 53 feet away. Notice my distance can be represented by what kind of line?
Horizontal.
A horizontal line. And then my angle of elevation from the hub of the turbine to me is 56.5 degrees. So I've got this nice little triangle here, 56.5 degrees of elevation. Your eye level is 5.5 feet above the ground. So what I'm saying is, here's my eye. If I start from my eye and I go directly to the ground, that's 5.5 feet. That would also be represented by this length right here. So that length is going to be what?
Congruent to that length.
Yeah. So that length is going to, I can't erase. That length is going to be, what? How much? 5.5. So that yellow highlighted part of the wind turbine is 5.5. 5.5. Now, there's obviously going to be a height associated with this distance right here. And we will highlight that in some really cool color, let's say red. And that length is going to be represented by the letter what? X. Because we got a little X already in there. You might not be able to see it because of the picture. So the red line is X, the yellow line is 5.5, and X plus 5.5 would make the distance from the hub to the ground. And that's what we're looking for. We're looking for the distance to the hub to the ground. It says approximately. Since I've got some units rounded off already to the nearest tenth, I think I'm going to find my answer from the nearest tenth of a foot from the hub to the ground. Everybody okay with that? Good. All right, so now it's just setting up a trig. So I've got an angle. I've got this line here. What kind of line is this with relationship to my angle? It's horizontal, but what is it with relationship to my angle? Adjacent. Why is it adjacent? Because it touches that angle. What's X?
Opposite.
The opposite. What trig function goes with opposite and adjacent? Tangent. So we're going to do a tangent angle of 56.5 degrees. Remember, tangent is a function. And that's going to equal the opposite X over the adjacent 53. And this is going to allow me to find out in feet how long the red part of the wind turbine thing is. All right? So I'm just going to plug this into my calculator. Well, first I have to solve for X. When I solve for X, I get X is equal to 53 times tangent 56.5 degrees. So I'm going to put that in my calculator right now. First thing I'm going to do is test my calculator. I'm going to do tangent 45. That gives me a value of 1. I know I'm in the right mode. So 53 tangent 56.5 gives me 80.07. I'm going to round that off to 80.1. So if X is equal to 80.1, and then the yellow line is 5.5, then my answer will equal 80.1 plus 5.5, and that's 85.6 feet. And that is how tall that sucker is. This technique is actually used a lot by surveyors and whatnot for determining things like how tall an object is that I don't want to climb up on the top of while its blades are spinning so that it would cut me. They've got these little devices called sextants that you can set them up and they can measure an angle of elevation. And once you know an actual angle of elevation and how far your sextant is away from your object, you can determine the height of your object. You can find the height of a bridge. And so this is very important when you're constructing things, when you're building buildings. Very important for engineers, very important for contractors, very important type of stuff. This math is huge. This math is what allows you to exist in the society you now live in. Without it, you couldn't. You'd be in a cave somewhere. All right, let's take a look at another problem. And these are word problems, and they're kind of wordy, and they're kind of intricate. Dissect them, break them down. So to approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent. So I've got an angle of descent or an angle of depression. However, when I draw my triangle, is that angle actually going to be inside the triangle? What angle do I need? I need this angle down here. Well, what's the relationship between this angle and this angle? They're congruent. Why?
Because opposite angles
Right. So I can go ahead and say that that is 3 degrees right there, because that angle is congruent to that angle. And so now I've got some more information. Okay, starting from a height of 2714 above sea level, so the plane is 2714. I'm going to do 2714. I'm going to turn it into an object, and I'm going to rotate it on its side because I can't write that well. But that length right there is 2714. However, that doesn't tell us how tall this triangle is, does it? This is what I need. I also know that the distance from here to here has a value of 1007. So once again, I'll write that down. I'll rotate it on its side, and I'll put that over here. So if I know that this whole thing is 2714 and this part is 1007, then when I'm looking at the triangle that I'm actually going to use trig on, how is this? How long is this? How would I find it? You have to kind of use some logical reasoning here. If I know that this whole thing is 2714 and this part is 1007, what's this part? Yeah, so I do 2714 minus 1007. I would do a subtraction problem. So 2714 minus 1007 is going to give me 1707. So 1707 is now the height of the triangle that I want to use. And so can I use trig to solve this?
Yes.
I can. What trig function would I use? Opposite, hypotenuse, sine. So sine of 3 degrees is equal to the opposite, 1707, over the hypotenuse, x. When I cross multiply and solve, what is x going to equal?
1707.
Yep, 1707 over sine of 3. Sorry. And so when I put that into the calculator, my approximation is 1707 divided by sine 3 degrees, 32,616. 32,616 feet. And maybe I might want to have you convert that into miles, I don't know. But that's the answer for this particular problem. Homework tonight is on Edmodo on your pacing guide.